Hello everyone. This is the extended version of the experiment number 1. In experiment 1, we used Langchain's OpenAI module to classify 100 Wikipedia articles into 50 different categories. In today's experiment, we are going to optimize the code a little bit and use Langchain's ChatOpenAI module, which offers flexibility in terms of conversational abilities on cost calculations and other capabilities as well. Let's get started. Let's start with cleaning up the imports. We're not going to use tick token library because ChatOpenAI, on every successful response, it returns the total number of input tokens, total number of output tokens, and overall tokens used for that particular request, using which we can accurately calculate the cost. So we no longer need tick token, and we are not going to use LLM chain, and we are also not going to use the output parser. Instead, we are going to instruct the OpenAI LLM to respond in JSON format, and we are going to do this only with the templates. Other two changes that we are going to make is, instead of using OpenAI module, we are going to use ChatOpenAI, and here instead of the prompt template, we are going to use ChatPromptTemplate. So the ChatPromptTemplate and ChatOpenAI are much helpful in terms of conversational abilities. So let's go ahead and import all these necessary items. I'm not touching the dataset part. Let it remain the same. We are going to load this dataset, which contains 10,000 articles, and here it is the random index in article 4, and basically this is a list of articles, list of strings, which we are going to classify. The next step is initializing OpenAI environment. Let's run this and paste our OpenAI key. Now the OpenAI key is set in the environment, and let's initialize the LLM. While initializing, instead of OpenAI, we are going to use ChatOpenAI. Let's run this, and now you can see the model name is GPT-3.fit Turbo. And we are not going to use output parsers. Let's remove it, and let's move to the prompt section. In the prompt section, we are going to initialize the chat prompt. To do that, we are going to use ChatPromptTemplate. From messages, usually it's a list, and first will be the system prompt. Here we have to specify our system prompt, and the next will be the user prompt, which is human. Okay. In the system prompt, we'll be providing all the instructions. Here are our instructions. Let's copy this and paste it. And in the human prompt, we are going to give only the input. So here are the instructions where we are specifying that the article needs to be categorized into one among these 50 categories, and the output should be in a JSON format, in this particular format. And in the user prompt, we are just going to pass in the article. That's it. And we no longer need this, this, and this. All we have to do is just run this. So this is our chat prompt template. Let's assign it to the variable prompt, and this is our prompt. And the next step is to build the chain. For the chain, we just need the prompt and the LLM. So this is the prompt that we are going to send it to OpenAI. So the first thing will be the system prompt with the instruction, and next one will be the article. And that's how our chain is built. First, we are sending the prompt, and it goes to the LLM, and we get the output as the response. Okay, so let's move to the next step, which is inference. We have initialized the chain. We no longer need this cost estimation section because we are going to use ChatOpenAI's output and perform the calculations for the cost estimation. Before we run the inference for all these articles, let's try a sample inference. I'm going to run a sample inference. Okay. To do that, I'm going to pick a random article. Let's say index number 2. It talks about alphabet A. The way we run the inference is chain.invoke, and we have to pass in the variable which we have set in the user prompt, right? So what we have to do is just create a dictionary and look for the variable. It's article. So let's pass the article, and the article that we are going to classify is the index number 2, right? So let's run this. As you can see, when we perform the same chain.invoke using OpenAI module, the response was only the classified category. But in terms of chat OpenAI, we get additional information. Let's save this to a response variable. Response. Let's print the response. And here we can see the response, the content talks about the exact output, which is our category. Response metadata gives us the information about the total number of input that we have sent into LLM, which is 397, and the number of completion tokens, which is the number of tokens generated as output, and the total number of tokens which has been written, which means 408. So for classifying this particular article, we have used 408 tokens. Let's go ahead and clean up the inference section. We are going to remove all these conditions. We no longer need this. In terms of chat OpenAI, we can see the output is a list of contents where we are having the category name and also the information about the tokens. And hence I'm going to, whenever I get the result, I'm just going to append it to a list. So results.append of result. We are going to run it only for the first 100 articles since it's a demo. And I'm going to remove the break statement, and yeah, so here we are going to results.append of, so it's going to be an empty string, right? So let's go ahead and run this for the 100 articles. It's going to take a minute. Let's wait until this gets completed. The execution is done. It took 1 minute and 14 seconds to classify 100 articles. In the next video, we are going to perform optimization to improve this timing, and we are going to optimize it to 30 seconds, less than 30 seconds, and we can classify all these 100 articles. Now, let's write a little bit of post-processing code. We don't want the results to be the list of AI messages. We need the category names. To do that, I'm just going to results of 0 dot. So this is a single message, and this is the content, right? Let's go ahead and write a list comprehension. So x of content for x in results, right? So here we have the results, but it's not yet loaded in the JSON format. Let's load it. JSON dot loads. Now we can see we have list of categories. Let's store it in variable categories list equals this, right? To map these results to the original IDs, I need IDs column. So let me go to the top here. All I have to do is take this and come down. IDs is this. Now let's print the length of IDs and length of category list. Let's check. Okay, length of IDs is 10,000. We don't need 10,000. We just need first 100, right? So let's do this. Now we have 100 IDs, first 100 IDs, and the corresponding output, right? So we can just create it as a data frame. ID, and my IDs is going to be IDs, and my category is going to be the category list, right? Now you can see this is the categories, and even we can get rid of this JSON. What we can do is add this here and run it again. Now we can see we have the data frame with 100 articles, their corresponding IDs, and their corresponding categories. We haven't evaluated the output. Let's randomly check a couple of articles and see if the output is correct. Let's take our favorite article, article number 2, which is about alphabet A. Let's print the results of 2, or even category list of 2, right? It's linguistic, correct. Let's take 3, which is Alabama is a state. and it's tagged to geography. And let's do 4 Greek mythology. Let's tag to mythology. Yes. Let's quickly perform the cost estimation. Results variable. We have the respective category and also the information about the number of tokens in the response metadata, right? So it's under total usage. Let's do token usage. Okay. So let's quickly write a list comprehension and get all this information for all those articles, right? So let's put it as a list, and I'm going to do X for X in results, right? So now we have the completion token, the input tokens, and the total tokens for all the 100 articles. Let's do pd.data frame of this, right? So we have it as a data frame. Let's name it as cost df dot shape. We know that for the input tokens, OpenAI charges $1.5. Let's look into the pricing. For input tokens, it's $1.5 per million token, and for output tokens, it's $2 per million tokens. What we can do is to find the total number of input tokens. Input tokens is nothing but cost df of, okay, we didn't name this columns, I believe. Okay, it's there, cost df of prompt tokens, and let's do the sum, and sum and output tokens is nothing but cost df of total, completion tokens dot sum, right? Let's print the total number of input tokens and total number of output tokens. Here you go. So for the input tokens, we have to multiply it by 1.5 and divide it by 1 million. Let's do 10 power 6, right? So this is the cost for the total number of input tokens. And for the output tokens, we are going to get charged $2. So it's going to be the same, but let's copy this, paste it here. Output tokens is going to be $2 per million tokens, right? So this is going to be the overall cost for 100 articles. As we see, the Langchain's ChatOpenAI module provides a lot of flexibility in terms of returning the number of tokens which is being consumed, and the flexibility in terms of using the prompts. In this case, we have used only one system prompt and one human prompt. In terms of chaining, or when we build RAG applications, the chat prompt template is really useful because we can provide multiple prompts as a conversation, right? So in the next step, we are going to optimize the batching, for which this ChatOpenAI model is going to be very helpful. I have published this notebook in GitHub, and I have put a link in the description. I hope this video was helpful. If so, hit the like button and subscribe to the channel. Thank you.